Okay, so this is section 9, topic 5. And it is called graphing exponential functions. The target. Y'all need me to zoom in more? Can everybody see that okay? Very good. Okay. Target. How do you graph exponential functions? How do you determine the y-intercept? And how do you determine if the function is a growth or a decay? All right. Let's kind of write, we're going to write the definition of a function, of an exponential function, and the important parts that you need to know. A function in the form f of x equals b raised to the x, or f of x equals a times b raised to the x is called an exponential function when b is greater than 0, comma, b cannot equal 1, and x is a real number. So b has to be some number greater than 0, but it cannot equal 1. So any number greater than 0 but not 1. Okay, cannot be negative, cannot be less than 0. And x, which is your exponent in exponential functions, has to be a real number. So if it's an imaginary number, then it's not an exponential function. The value of a is your y-intercept, which we know y-intercept means where does your graph cross the y-axis, right? Period. If b is greater than 1, the function is a growth. And if b is less than 1, the function is a decay. So a lot of kids say, well, what if b is equal to 1? Well, by definition of an exponential function, b can't equal 1. It's got to be greater than 1 or less than 1, but also greater than 0. So b has to be somewhere between greater than or equal to 0, but less than or equal to 1 to be a decay. And anything greater than 1, it would be a growth. All right? So these are our exponential function basics. So pretty much we answered everything in the target already. The only thing we did not answer is how do you graph exponential functions. How do you determine the y-intercept? We already said the value of a is your y-intercept, so we know that part. How do you determine if the function is a growth or a decay? We said that as well. If b is greater than 1, the function's a growth. If b is less than 1, the function's a decay. So now I'm going to teach you how to graph it. All right? Anybody have questions so far? Example 1. Graph the following exponential functions. On the same plane. Means we're going to put them both on the same graph, not two separate graphs, okay? So we have f of x equals 2 raised to the x, and we have g of x equals 4 raised to the x. Now for function f, is that in b to the x form or a times b to the x? B to the x. So what is a? There's not one there. What's a going to be? That would be 0 times 2 raised to the x is just 0. 1, right, when we're multiplying? So what would my y-intercept be? 1. There's a 1 there. It's just implied. So that's your y-intercept. Same thing on function g. It just has a b to the x, right? Whichever has your exponent, that's your b. Okay? What it's being multiplied by is your a. If there's nothing there, it's a 1. So g also has a y-intercept of 1. Function f, is that a growth or a decay? It is a growth. Why? Because b is greater than 1. Very good. Same thing on function g. We know it's a growth because b is greater than 1. And I should put a 0. I meant 1. We watched algebra nation videos. Remember topic 1 and 2 where they were graphing exponential growths and decays? As x increases, if y is decreasing, like that Ford Mustang, remember we did that problem? The value is decreasing. That was a decay. If x is increasing and y is also increasing, like the value of that Gibson guitar, remember? As the years went by, the value was increasing. That would be a growth. Okay? So to graph this, we know the y-intercept, we know it's a growth, but we need some more ordered pairs on our graph. So I'm going to make a big graph at the bottom, and just so that you know, our graph is pretty much, well, the whole thing is above the x-axis. So I'm not going to show very much of the y-axis. And I'm going to make my y-axis go all the way up to positive 16. Also going to leave enough room for a table of values, just so you have that in mind when you're drawing your own graph. Okay? Me personally, I'm using a ruler to make it straight. You don't have to. You also can use the straight edge of your ID. And I'm going to go ahead and put my little table of values over to the right. And I'm choosing my own values of x, -2, -1, 0, 1, and 2. If I want more values, I can choose more values. That's just a good starting point. Some negatives, 0, and positives, but I can add more to it, okay? So the math is going to trip you up a little bit. We already learned what to do when you have negative exponents. We just have to remember our last test, we had negative exponents. So if I were you, make sure when I'm showing my little math over here on the side that you do as well, so that when you have to do this on your own, you go back and look at it and you don't remember how did I get that answer and oh, I didn't put that in my notes, that you have it in your notes so you can go back and look at it, okay, at least at the beginning. So I'm going to do function f first. And these are my values for x. I'm going to substitute them into the function to find the values for y, or f of x, okay? So I'm going to find f of -2 first. And I'm kind of going to write small because I got a lot of math to do. So I'm substituting that in 2 raised to the x. But if x is -2, that would be 2 raised to the -2. Try to zoom that in for a little bit. Y'all remember what happens when you have a negative exponent, how to get rid of it? Yeah, if it's in the numerator, if I move the base to the denominator, it changes the sign of the exponent, right? If it's in the denominator and I want to change the sign of the exponent, I would move it to the numerator. But in this case, I will move 2 to the denominator, and that changes the sign of the exponent. And since there's nothing left for the numerator, I just put a 1 up there. So instead of 1 over 2 squared, what is that exactly? 1/4. So when x is -2, y is 1/4 in function f. I'm going to do all the function f first. Do we have questions about that? So let's do f of -1. So that's 2 raised to the -1, which if we get rid of the negative exponent, that would be 1 over 2 to the first, which we just call that 1/2. Do I need to show my work for f to the 0? No. What's anything raised to the 0 power? 1. I did anyway, but how about 2 to the first? 2. How about 2 to the second? 4. All right, so let me go ahead and plot those points. Is everybody good with how I got that? So for function f, when x is -2, y is 1/4. When x is -1, y is 1/2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. Now, say you're doing a standardized test and you have all different kind of functions, not just exponential functions, and you're like, I don't really remember what the graph of an exponential function is supposed to look like. Is this going to like be shaped like a U, like a parabola? I don't remember. Is this supposed to be a straight line and I just am off a little bit? I might figure out some other ordered pairs to help me remember. So when we could do this in our head now, what if x was 3? That would be 2 cubed, which is 8. Well, what if f was -3? What would that be? Look at your table of values. See a little pattern there? When x is 2, y is 4. When x is -2, y is 1/4. When x is 1, y is 2. When x is negative 1, y is 1/2. So what do you think negative 3 is? 1/8. Let me plot those. When x is 3, 1, 2, 3. Y is 1, 2, 3, 4, 5, 6, 7, 8. And when x is negative 3, y is 1/8. Let me see when x is 4 if I could fit that on there on my graph. So 2 raised to the 4th power, 2 times 2 is 4, 4 times 2 is 8, times 2 is 16. We would get 4 comma 16, right? Well, what about when f is negative 4? What do you think we get? 1/16. So I'll plot those. Now remember, do y'all remember what asymptotes are? One yes. Remember, asymptotes is some types of graphs have asymptotes. When we graphed rational functions, those were those crazy ones, right? You could have like 3 parts, like the middle part goes like this, and the bottom part is this way, and it had asymptotes that could approach. Well, when you graph exponential functions, it has asymptotes. So it's looking like 0 might be our asymptote because the line keeps approaching it, but it hasn't crossed it yet. Let's just in our head say, okay, if x was 100, 2 to the 100th, 2 raised up to the 100th power that is the decimal move to the left 30 times. That's a huge number, right? So if it was negative 100, it would be 1 over that really large number. So is that a 0? No. So even when x is 100, it still is not 0. So you see how it keeps getting closer to 0, but it's never going to reach 0. So that's how we say, or that's how we know that y equals x, which is the equation of the horizontal line that crosses the y-axis at 0, is our asymptote. That says y equals x is asymptote. That's the equation of the horizontal line that crosses the y-axis at 0. And then I'm going to so exponential functions, they start, if it's a growth, increasing very slowly, and then once they get to a certain point, they just take off. They increase exponentially. They're increasing at the same rate the whole entire time, but when you have tiny, tiny, tiny fractions, it's hard to see them increasing until they get to a certain point, okay? So we know this is a growth. We said it was going to be because b was greater than 1, and we can tell graphically that as our x's increase, our y's increase. Same with the table, so we know that that's an exponential growth, right? 3 ways that we can tell. Do you have a question, ma'am? Oh, you see it? Okay, so now let's do g of x. I'm going to use those same x values, and if I want to choose more like I did for f, we can do that. So, but our function now is g of x equals 4 raised to the x. I'm going to do my math over here if I can. So I'm going to find g of negative 2. So that would be 4 raised to the negative 2. Well, we know we're going to get rid of that negative exponent. So 1 over 4 squared is what? 1/16. Now let me do negative 1. G of negative 1 equals 4 raised to the negative 1. What are we going to have there? 1/4. What is g to the 0? 1. What is g to the first power, which would be 4 raised to the first? 4. What about g squared? 16. So notice when we had function f, what were the y values doing to get to the next? When x was increasing by 1, what were the y values doing? Doubling, right? So multiply by 2 to get to the next y value, the next consecutive. For a function g, when x increases by 1, what are the y values doing? They're quadrupling, right? Do you think that has anything to do with the base? Yeah. And it's not going to be so obvious. If your y-intercept is some number other than 1, that won't be so obvious by looking at the table of values. But if your y-intercept is 1, then it's easy to see what it's doing. Okay, so let me plot these numbers. When x is negative 2, y is 1/16. When x is negative 1, y is 1/4. When x is 0, y is 1. We had that same ordered pair on function f. When x is 1, y is 4. When x is 2, y is 16. And we don't really need to pick other ordered pairs like we did before because this one quadrupled each time, so if we pick more, they're just going to be off of our graph. We could pick more negatives, but you would see it would just keep getting closer and closer and closer to 0, but it's never going to approach 0 and it's never going to go below 0. Does that make sense? That's why our asymptote is at y equals 0 for both of these. Now, if we were adding a number onto these functions or subtracting a number, that would make our graph go up or down depending on if we were adding or subtracting. Then our asymptote would go up or down with it. Okay, your asymptote's not always at y equals 0 or y equals x. It should be y equals 0. Not x, I'm sorry. Change that. Y equals 0. Y equals x is a line with a slope of 1. Sorry about that. No one said anything. Y equals 0. So are these both growths? Yes. They both have a y-intercept of 1. If I asked you, what is the solution of, because these is basically a system of equations. We have two different equations, right? What is the solution to the system? 0, comma, 1. That's the ordered pair they have in common, right? 0, comma 1 is the solution. We can tell that by looking at the graph. I'm sorry, the table. The table, that's the only ordered pair they have in common. We can also tell it by looking at the graph because that's where they intersected, right? And we know the ordered pair that two functions have in common is the solution. So we weren't asked, but you will be. The solution is 0, comma 1. Any questions? So, I only have one more graph for you. The next one I'll go a little faster. All right? Everybody cool? How is it what? So I'm going to use my whole page for this one. It'll be basically the same as the last one. I just have more room to work. But I am going to want my y-axis to go all the way up to 16 again. And there's nothing going to be below the x-axis. So example 2. A little. Yeah, more of the right but into the left, yes. Like this. That's what it's going to look like. Zoom out a little. Okay? Graph the following exponential functions on the same plane. We have f of x equals 1/2 quantity raised to the x, and we have g of x equals 1/4 quantity raised to the x. For function f, what's the y-intercept? 1, right? So it's your a. And is function f a growth or a decay? A decay. And why is it a decay? B is less than what? 1. B is less than 1. Function g, y-intercept. 1 again, because there's nothing in a spot, so it's not 0 because we're multiplying. It's 1. And what is it, a growth or a decay? A decay again because b is less than 1. And I'm going to go ahead and draw my graph and my table of values just like we did on the last one. And I'm going to try to speed this process up because y'all do have an assignment. I'm going to make it go up to 16 again. You need me? I'm making an excellent video right now. Okay. Okay. By when? You have to know when by the end of next week? Oh, okay. You want me to look at my calendar and email you? Okay. Thank you. I like your headpiece.
Is it basically the same size graph?
Yeah, same size as the last one. I'm doing mine in as a fraction. Yeah. So, I mean, that's fine. It may be hundredths. Okay, so I know the y-intercept is 1 on both of them. That's not always going to be the y-intercept. It just so happens to be in both of our examples. Okay, there's a number there. That's whatever the y-intercept is, whatever's in A's place. So, and I know they're both decay, so I know from left to right the y values are going to decrease. Okay, but I need to find some more points. So I chose these values for x. It's good to pick negatives, 0, and positives. If I need more, I can pick more. So I'm going to do f of x first. I'm going to find f of negative 2, and I'm substituting that into 1/2 raised to the x. In this case, that would be negative 2. Okay, now remember, 1 is being raised to the negative 2, and also 2 is being raised to the negative 2. So the numerator has a negative exponent, and the denominator has a negative exponent, okay? So when you're doing negative exponents, you don't just, people say, just flip the fraction. Well, not necessarily, but if your numerator is negative and your denominator has a negative exponent, then yes. So if we just rewrite this as 2 over 1, that will change this negative exponent that goes to both the numerator and the denominator to a positive. Okay? And isn't 2 over 1 the same thing as 2? And what is 2 squared? 4. So when x is negative 2, y is 4, or f of x is 4, however you want to say it. So let's do f of negative 1. That would be 1/2 raised to the negative 1. So to get rid of that negative exponent, I know 1 is raised to the negative 1 and 2 is raised to the negative 1. So if I just write the reciprocal in this case, that would change the exponent to positive 1. We know 2 divided by 1 is 2, and 2 raised to the first power is 2. What about when f is 0? What is x or y? 1, right? Anytime you have exponent of 0, simplified, you get 1. What is 1/2 raised to the first power? 1/2. What is 1/2 raised to the second power? What'd you say? It was right. 1/4. Good job. Well, a lot of people say 2/4. 1/2 squared means 1 squared over 2 squared. Or you could say 1/2 times 1/2. Either way, the result is 1/4. So let me plot this points. When x is negative 2, y is positive 4. When x is negative 1, y is 2. When x is 0, y is 1. When x is 1, y is 1/2. When x is 2, y is 1/4. I'm going to go ahead and find a few more values. If f is 3, that would be 1/2 raised to the third power, which means 1 cubed over 2 cubed. What is that? 1/8. So when x is 3, y is 1/8. So what if f was negative 3? What do you think that would be?
16.
Close. Negative 3. If f is 3 is 1/8, if f is negative 3, look at your pattern from your table. It would be just 8, right? I'll plot that. You was thinking I would move to the 4. If f is 4, that would be 1/2 raised to the 4th, which means 1 raised to the 4th over 2 raised to the 4th. What would that be? 1/16. So f to the negative 4 would be what? Just 16, right? Okay. So I'm going to go and plot those, and that should be enough. So when f is 4, I get 1/16. When f is negative 4, I get 16. So again, you can see that my asymptote is going to be at y equals 0 again. Bless you. Bless you. And we said it was going to be a decay. We can tell graphically it is. We can tell by the table it is. As x's increase, my y values decrease, right? Anybody have a question about the math on that? Okay. Okay, let me do function G. Notice on these, that on the last one we did, it was doubling. This one there, yeah, you're dividing by 2 each time, right? All right, for g of x, I am doing g of x equals 1/4 raised to the x. So I'm doing g of -2 first. That's 1/4 raised to the -2. I'm going to go kind of fast on this. If you need to see my paper afterwards of my math, that's fine. But I want to make sure you have time to get your homework down. So we know if I write the reciprocal of that, it will change my exponent to +2. 4 divided by 1 is 4, and 4 squared is 16. G of -1 equals 1/4 raised to the -1. I could rewrite that as 4/1 raised to the +1. 4 divided by 1 is 4. 4 raised to the first is 4. What is g to the 0? 1. G of 1 means 1/4 raised to the first power, 1/4. G of 2 is 1/4 quantity squared, which would be 1/16. And that should be enough there because that spans all the way to 16 on my y-axis, so I should be good. When x is -2, y is 16. When x is -1, y is 4. When x is 0, y is 1. Right there we can see that's going to be our solution, right? That's the ordered pair they have in common. They're not going to intersect more than once. When x is 1, y is 1/4. When x is 2, y is 1/16. That one would have the same asymptote. Oh, I didn't make that very pretty. The same asymptote as the other function, y equals 0. So we already said the solution when f of x equals g of x is at 0, 1. We can see that by looking at the table of values. We can also see that by looking at the graph. Does anybody have questions about this? Now, on the assignment that I'm going to give you, I'm going to have you graph 2 functions on the same graph, just like I just did. But just so you know, one's going to be a growth and one's going to be a decay. I just don't want you to be confused because on these, 2 are growths, 2 are decays on the same graph. It'll be one will be a growth, one a decay. It doesn't matter. You still find the table of values, do everything like you did before. Okay? So you may have questions on this? All right.
Can I see the g of x?
Yeah, let me just pause this and then you can